Okay, in this video, we are going to cover completing the square. So you may have learned how to complete the square when you were learning how to solve quadratics that were not factorable. Okay, so let's have a look. Okay, so what happens is, suppose that you have an equation like this that you need to solve. So we'll start off with using completing the square to solve equations, and then we'll take a look at using completing the square to rewrite a quadratic in standard form. Okay, suppose that I have this equation here. If I want to solve this, I could factor this if it's factorable and solve, or I can use another method called completing the square. And the goal of completing the square is to get some sort of a binomial on this side, like let's say we have x plus 3 squared. Okay, so we have to figure out how to have a trinomial here on the left-hand side so that it factors nicely to a binomial squared equals some number like, let's say, 5. Okay, because once it's in this form, then it's very easy to solve this because now we can just take the square root of both sides. Okay, so our goal is to try to get it to look like this so that we can take the square root and finish solving. Okay, so over here, what happens is that's not even a perfect square. So what we do is we're going to go ahead and add 24 to both sides. So then that will leave me with x squared plus 2x. And what I'm doing here is I'm actually looking for a third term that makes a perfect square. Okay, but if I'm going to add a number on the left-hand side, then I also need to add that same number on the right-hand side. So the way you go about finding this number here is by taking half of this number and then squaring it. So half of that number and then squaring it. So that becomes 2 divided by 2 is 1. So I'm just going to write it as 1 squared. And 1 squared is actually 1. Okay. And what happens is now the trinomial that you have on the right-hand side over here, this trinomial factors into a perfect square. It turns out that that factors out to x. And then I'm going to use this sign right over here, plus, and I'm going to use this number inside that we end up squaring, which is 1. Okay, and on this side, on the right-hand side, I get 25. So now I have a form that looks like this in here, which was my goal. And so now I can take the square root of both sides. And when I do that, I get plus minus the square root on the other side. And I get x plus 1 is equal to plus or minus 5. And then I finish solving for x by subtracting 1 on both sides. So I get -1 plus or minus 5. So I have two answers here, -1 plus 5. So I'll do that answer up here, -1 plus 5, and that is 4. And then I have my second answer down here, which is -1 minus 5, which is -6. So those are my two answers. X equals 4 and x equals -6. Okay. This is for solving. This is how we use completing the square to solve. the completing the square for rewriting an equation, we would normally stop right here because the rest of this down below is solving. Okay, so for the rest of the problems, I won't continue solving. I will stop at this point. Okay, let's take a look at another example. Suppose that I have this. Okay, and I want to complete the square. So that means I will move this 54 over. Okay, so now I have x squared plus 12x, and now I will try to find another number. And this here is always plus. And the reason why is because when you square a binomial, let's go back to something like this. When you square this, you end up with x squared and then 6x and then 3 times 3. So this last term here in the trinomial, the way you get that is by taking whatever is here, positive 3 or negative 3, and squaring it. Whenever you square a number, you always end up with positive. So that's why this here, this third term is always going to be plus. Okay, and if we add on that side, we need to add on this side. Okay, so here we're going to take half of 12. So 12 divided by 2 is 6, and I'm going to square that. And that becomes 36. You can write 6 squared or you can write 36. So this side factors out to the square of a binomial, and that's going to be x. And again, I use this sign over here, and I use the number that's in here, 6. Quantity squared equals to 90. Okay, so I'm just going to stop right there because the goal is not to solve these, but to complete the square so that it's written like this, which is almost standard form for quadratics. Okay, let's take a look at another example. X squared minus 8x plus 15 equals 0. So here I'm going to subtract 15 on both sides. And I have x squared minus 8x plus something. And again, if you add something on the left, you have to add that same thing to the right. And here I'm going to take half of 8, and square it. Well, half of 8 is 4. So I'm adding 4 squared on both sides. Okay. So here, when you complete that square, it factors out to a nice binomial. Again, x, and I'm going to use this sign over here. And I'm going to use 8 divided by 2, which is 4. And on this side, when I work that out, I get 1. Okay? And I'm going to stop right there. And let's take a look at this next example. X squared minus 4x minus 91 equals 0. Okay, so I'm going to add 91, both sides. So I have x squared minus 4x. And over here I have 91. Okay, so let's find that nice third term here. So I'm going to take half of 4 and square it. Half of 4 is 2. Okay, so half of 4 and square it. Half of 4 is 2. Okay. And so again, this factors out nicely to the square of a binomial. So I'm going to have x here. Again, I use this sign, and I use the number inside here, which is 2. And on this side, I get 95. Okay. Now, these first 4 examples are quite simple because of 2 things. All of them here have a leading coefficient of 1, and all of them also had a second term here that was an even number. So let's take a look here at an example where we'll still have leading coefficient 1, but we will have an odd number. The process is still the same. It's just that now, because that's an odd number, and to find that nice third term like we did here, we divide by 2. Well, now that middle number is not going to be divisible by 2. Okay, so let's see what happens. We still add 1 to both sides. Okay, and then I take half of 3 and square it. So I'm going to write it like this. And I like to keep it as a fraction. So 3 over 2 squared is going to be 9 over 4. Okay. So again, this side factors out to a square of a binomial. It's going to be x. We're going to use this sign. So it's plus. And over here, we're going to have 3 over 2. Okay. And then on the right-hand side, you can do the math there, and you should get 13 over 4. So that's the only difference between having an even number versus an odd number for that middle term. Okay, so the only difference is that when it's odd, we introduce fractions. Okay, so let's take a look at what happens when we don't have 1 here. Like, let's suppose we have a 5 or a 3 there. Okay, so suppose that I have this one, 5x squared minus 20x plus 6 equals 0. Okay, so again, we still start off the same. Subtract 6. Okay, so right here, this is the part that's a little tricky. Okay, so what ends up happening over here is, because we have a 5, we're going to go ahead and factor out a 5 from all 3 of these terms. So I'm going to have 5 parentheses x squared minus 4x, and I'll still leave this blank. Okay, but now when you look inside the parentheses, we see that the leading coefficient, which is the coefficient next to x squared, is 1. So I can go ahead and complete the square. So over here for this third term, I'm going to take half of 4, which is 2, and I'm going to square it. Okay. Now, over here on the right-hand side, you're not actually adding 2 squared. You're going to be adding 2 squared times this 5 that's out here. So that's the only thing you have to make sure you pay attention to if you do any factoring. That whatever you add over here, if it's a 2 squared in here, don't forget to do the 2 squared times the 5 that's out here. Okay? And then the rest is still the same. So it's going to be x. And then I'm going to use this sign, minus, and then this is, oops, that's not a 2. Okay, so here is 2 squared equals -6 plus 20. Okay, so it turned out that it's 20 that we are actually adding, not just 2 squared. Okay, and so we get 5 times x minus 2 squared equals 14. Okay, and then we can continue solving for it. But again, we're using completing the square to write quadratics in standard form. Okay, so let's take a look at another one of these where the leading coefficient is not 1. So suppose that we have 3x squared minus 6x minus 34 equals 0. Okay, so again, we start off the same, add 34, both sides, and I end up with 3x squared minus 6x plus something equals 34 plus something. Okay, so I see that I have a 3 right here. Okay, so I'm going to factor out that 3 on the left-hand side. So I get x squared minus 2x plus blank equals 34 plus blank. Okay, so over here, I'm going to take half of 2, which is 1, and I'm going to square it. So I'm adding 1 squared on this side, but remember, we also have the 3 out here, so it's 3 times 1 squared. So this left-hand side will factor out to a binomial squared, and it's going to be x. I use this sign, minus, and I use the number inside here, which is 1. And on this side, I get 34 plus, let's just do that in our heads, 34 plus 3 times 1 squared, and that is going to be 37. Okay, so you can kind of see this looking like a standard form of a quadratic if you watched my video for 3.1. So let's actually take a look at how it differs. So this last example, let's take this quadratic equation and let's write y equals x squared minus 8x plus 15 in standard form. Okay, so here, I'm going to go ahead and write it down. And so instead of having a 0 on the other side of the equation, we have the variable y, okay? But the whole process is still the same, so I'm going to subtract 15 on both sides. Okay, it's just sort of getting out of the way right now, and then we're going to bring that back. Okay, so we have y minus 15 equals x squared minus 8x. Okay, and we want to find a term that we want to write over here. Okay, so here I'm going to put a plus blank. I didn't leave any room. Okay. All right, so again, to find that third term, we take half of 8, which is 4, and we square it. So we're going to be adding 4 squared. Okay, 4 squared is 16. So on the left-hand side, I'm going to get y plus 1. And on this side, this is going to be a square of a binomial, and it's going to be x. I'm going to use this sign right over here, minus, and I'm going to use this number that we squared. So I'm going to use 4, okay? And now that we have this binomial squared, then I can go ahead and bring this number back to this side. And so my equation is going to read x minus 4 squared minus 1. This here is your standard form. And we can see right off the bat that the vertex of the parabola is going to be at positive 4, negative 1. Okay? So if you still have any questions about how to rewrite the quadratic in standard form by completing the square, make sure you text me or email me, and I can set up a Zoom meeting with you, or I can just do another video where I do more examples.